Next is base of the object inaccessible. In that first case it is single plane method. In order to find out the difference in elevation of an elevated object, we are going to study in three cases. First one, it is instrument axis at the same level. Second one is instrument axis at different level. In this case, instrument axis at different level, there are three cases are there. When instrument B is higher than A, second one is instrument A is higher than B, and when the instrument A and B are at very different level. How to calculate the elevation of an elevated object, we will see one by one. We'll move on to the first case, that is instrument axis at the same level. How to calculate the RL of this Q and how to calculate the height of an object. We will see now the derivation, that is instrumental axis at the same level. This is the figure, this is the ground level. Then first is the A instrument station. This is the B second station, that is the B point, second instrument station. Distance between the two instrument station, it is denoted by B, and the distance from the first instrument station A to an elevated object, it is denoted by capital letter B, and H dash will be the height of the instrument of both A as well as B. This B dash will be the instrumental axis, B dash as well as A dash. S1 and S2 are the staff reading taken on the benchmark. S1 and S2 are equal because both the instrument are at the same level. Initially you need to set up the instrument at A point. You need to do all the temporary adjustments. Then you need to loosen that vertical clamp screw. Then you need to bisect an elevated object Q and note down the first vertical angle, that is alpha 1. Next, you need to shift the instrument to the B station, do all the temporary adjustments, and once again you bisect the elevated object Q and note down the second vertical angle, that is alpha 2. And H will be the height of an elevated object from the instrumental axis or the line of sight to an elevated object. It is denoted by H value. Now we will derive what is the formula to calculate H and what is the formula to calculate this D value, and the B distance will be known to you. Same as such of previous derivation from triangle, that is from the first instrument station, what is the formula to calculate H? Similarly, when it is from the second instrument station, what is the formula to calculate H value as well as D value? First we will see when the instrument it is at A point, what is the formula to calculate H value? From the triangle, that is A dash Q Q dash. A Q Q dash, apply the trigonometric function, that is tan alpha 1 will be equal to tan theta equals to opposite side will be H divided by adjacent side will be what? That is D value. Cross multiply that, H will be equal to D tan alpha 1. Call this as equation 2. Next, move on to the second instrument station. Consider the triangle, that is B dash Q Q dash, that is B Q Q dash, right? Apply once again the tan function, that is tan alpha 2 will be equal to opposite side is same, that is H divided by what will be the total distance from the second instrument station to this elevated object? It will be B plus D, is it not? B plus D. Then cross multiply, H will be equal to B plus D into tan alpha 2. Call this as equation 2. Now equating equation 1 and 2. Then the equating 1 and 2, it will be D tan alpha 1 will be equal to B plus D tan alpha 2. Right? That is D tan alpha 1. Simplify that equation, which will be equal to, bring this tan alpha 2 inside the bracket, that is B tan alpha 2 plus D into tan alpha 2. Your aim is to calculate, that is what is the formula to calculate D value. Okay, bring the D term in this to the one side and other to the other answer, that is the RHS side, that is D tan alpha 1 minus D tan alpha 2, that will be equal to B into tan alpha 2. Okay, next take D common term in this, then it will be tan alpha 1 minus of tan alpha 2, right? That will be equal to B into tan alpha 2. Okay, next you want, that is D equation. Okay, then D will be equal to, simplify this, B tan alpha 2 divided by tan alpha 1 minus tan alpha 2. This is the formula to calculate the distance of an elevated object from the instrument station. Okay, that is D equals to B tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Substitute in this H equation. Okay, either 1 or 2 in order to calculate that H value. Substitute the D value. Okay, substitute D value in equation 1. Okay, then H will be equal to, what is the formula? That is B into tan alpha 1 into tan alpha 2 divided by, right, that is tan alpha 1 minus tan alpha 2. This is the formula to calculate, that is H value. Once both, that is D value, you can substitute in equation 1 as well as equation 2. You will get a different H value. Okay, once you calculate, I am going to simplify, that is D value in one equation. Okay, similarly you substitute in the second equation. Okay, and calculate the H value. Next it is D, you have calculated the height of an elevated object, you know the formula. Next is to calculate, that is RL of Q. RL of Q, it is given by what? RL of Q equals to, if you are knowing RL of benchmark and the staff reading, the formula it is RL of benchmark, right? RL of benchmark plus the staff reading. Either you can write it S1 or S2, both are same because the instrument station are at the same level. I will take it as S1, right? S1 from the RL of benchmark plus S1 plus H. This is the formula to calculate RL of Q value. H is what? H you have derived it. H will be equal to B into tan alpha 1 into tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Okay, this is the formula. If they have given RL of the instrument station and the height of the instrument, the formula is given by RL of Q equals to RL of A or RL of B point, B station, or you can call it as, right, RL of B plus H dash plus H. This is the formula. Depending upon the given data, you need to use the formula. Okay, this is the formula.